Hi y'all. In this video we're going to look at the material for problem solving with systems of two linear equations containing two unknowns. And as the title might imply, each of the problems in this section will involve a system of two linear equations with two unknowns. And each of them is going to be able to be set up just like one of these in this format. That is, we're going to have a linear equation of the form ax plus by equals c and another one of the form dx plus ey equals f, where a, b, c, d, e, and f are all constants, and we have some variables x and y. This may look somewhat complicated, but this is just kind of like a set of equations, much like we saw in the last section, where we're going to end up with something like this, and we have different methods to solve those, such as substitution or elimination. Knowing that this is what we're looking for can greatly simplify the process of getting there. Let me say that again. If we know this is where we're going to end up, we kind of know more about what we're going to look at in the problem to get there. In example 1, we're told that Catherine has to think of two numbers to get to stay up later than her bedtime. Her daddy tells her that the sum of the two numbers is 35. He also tells her that one of the numbers is 2 larger than the other. What are the two numbers? To start off with almost all these problems, what we really want to do is we want to write down what the variable names represent. Let's call x the smaller number, and frequently we'll choose x and y. It doesn't always want to be that case. Sometimes we'll choose letters that are meaningful for the problem, but x and y will work pretty well here. And we'll have y be the larger number. One thing I always want to stress with this is you frequently will want to reread the problem more than once. We're asked here for both of the two numbers, so in our final answer we're going to want to make sure we have both numbers recorded. Now, rereading the problem again, we're going to notice a few things. The sum of the two numbers is 35. That's got to relate in some way to what these two variables are. And in particular, what we're going to see here is that should say that x plus y is 35. The second statement here, I'm going to underline that in green. We're told one of the numbers is 2 larger than the other. Alright, the smaller number is x. So if I take that x and I add 2 to it, I'm going to get the bigger number. That should give me y. Now if I look back, and you can do this on your paper that you printed out, you should see this doesn't look exactly like the format we saw earlier. But I could have written this, you don't have to, but you could have written this as x plus y equals 35, and rearranging the bottom term, you can do this for yourself to see this, as x minus y equals a negative 2. And this would fit that form. Looking at what we get when we just write down the process though, we'll notice this is already solved for y, that second equation, so I'm going to leave it alone and use substitution. So using the substitution method here, I know that y equals x plus 2 in that second equation. I'm going to take that x plus 2 and plug it in for y in the first equation. So I'll get x plus, let me make that red, x plus 2, which was y, equals, from the first equation, 35. Writing this out, we'll see that 2x plus 2 should equal 35. Subtracting 2 from both sides gives us 2x equals 33. Dividing both sides by 2 here, we'll see that x should equal 16.5, which is the equivalent to 33 halves. Looking at our second equation there, which was already solved for y, we see that y should equal x plus 2, which in this case means that y will equal 16.5 plus 2, or 18.5. So our solution of this system of equations will be 16.5 for x and 18.5 for y. Sometimes we'll write that as an ordered pair, which in this case would be 16.5, 18.5. And with that, Catherine could stay up past her bedtime. Example 2 reads, suppose that you received a windfall of $50,000. You just got $50,000 in cash. You decide to invest the money. Not wanting to put all of your eggs in one basket, so to speak, you plan to put some money into stocks and some money into bonds. If you want to have 3 times as much money in stocks as you have in bonds, how much should you put into each asset class? Alright, so looking at this, we have stocks, let's call it S, is the amount of money put into stocks. And bonds, well, this should be something similar. I'm going to cheat. Alright, so I have S is the amount of money put into stocks, and B is the amount of money put into bonds. Their first equation, or the first line that will help us here, is to notice I got a total of $50,000. If you read through here, you're putting some in stocks and some in bonds. Well, I'm pretty sure what that's telling me is then that S plus B will equal 50,000. I'll point out here, if you want to call this X and Y, that's fine too, but I prefer to use meaningful names when I can. Second line, you want to have 3 times as much money in stocks as you have in bonds. What that's going to tell me is there's some relationship between here, B and S. I want 3 times as much in stocks as in bonds. Well, that means the bond amount is smaller, and it's the one I should be multiplying by 3. Again, this is really fitting the right format. So we have S plus B, those are our variables, equals 50,000. The second one, I could have rewritten subtracting the S from both sides as a negative S plus 3B equals 0. So this is really the right format. This is a system of linear equations with 2 unknowns, S and B, and 2 equations. Again, this is just set up for us to use substitution. We have S solved for in the second equation, substitution. I have S solved for in the second equation. I can just take that 3B, plug it into the first equation, and I'm good to go. So doing that, I'll leave this as red. We'll get 3B plus B equals 50,000. Well, I'm pretty sure that's going to be 4B equals 50,000, dividing both sides by 4. I'm going to get my results, and thinking through this, this should be $12,500 are going into bonds. I have my equation for S, that's equal to 3 times B, so that will be 3 times 12,500 here. One too many zeros there. Or $37,500. So here's my B, and here's my S. I'll note here, since I use the variables B and S, this doesn't necessarily naturally lend itself to writing this as an ordered pair. So you need to be really careful about the order you put these in. So if someone tells you write it as SB or BS, gotta be careful with that. Make sure you put it in the right order. In example 3, we read, on a 12-hour trip from Ohio to the Outer Banks, the Jordan family stopped 2 times for snacks. In West Virginia, they ordered 3 large drinks and 4 sub sandwiches, and the total cost was $22.25. A few hours later, they stopped again in North Carolina and ordered 2 large drinks and 3 sub sandwiches for $16.25. How much did each large drink cost? How much did each sub cost? And we're told to assume the drinks and subs cost the same at each location. Alright, one thing about this problem is I want you to pause the video, reread it a couple of times, and then we're going to talk about it. Alright, welcome back. Now, when I read through this, and this is something I want you to pay attention to, you really want to read through it the first time and look through everything that you see. My questions here are really where I need to start. How much did each large drink cost? Well, that's going to tell me I need a variable for that. Let's call it D, cost of a large drink. Almost always, you want a variable name for the question being asked. The second question was, how much did each sub cost? Let's have that be S. Cost of each sub. Alright, after that, you're going to notice in here, you got some details here. On a 12-hour trip, I don't care, I don't care, I don't care, I don't care, I don't care. I kind of care, but not really important. Don't really care where they're stopping. Not really important. Alright, that makes it more interesting. But you want to kind of not pay too much attention to these details. What you want to focus on is what played a role in this first stop, what played a role in this second stop, and what these things mean. So at the first stop, they ordered 3 large drinks, they ordered 4 sub sandwiches, and they cost $22.25. The 3 large drinks. Each drink costs, well, I don't know what it is, but I'm calling it D. Each drink costs D. So if I'm ordering 3 drinks, well, each one costs D. Let's kind of side example. I'm going to write this down. You don't have to. But let's kind of think through this. Let's suppose I knew the answer and each drink cost $2. If I got 3 drinks, how much would that cost? Well, that would be 3 times 2, or 6. It's not actually important here that D was 2. It's important that I took 3 times that amount. What I want to notice about the cost of 3 drinks is that it's 3 times D. 3 times D gives me the amount that 3 drinks should cost. So at the first stop, the drinks cost a total of 3D. I also bought 4 sub sandwiches. Well, the total cost for that in a very similar way would be 4S. The total cost was $22.25. Adding those two amounts together, I get $22.25. And that's my first linear equation. The second one, very similar. Let's kind of use blue for the second one. Well, I already used blue. Let's use green. 2 large drinks, 3 sub sandwiches, $16.25. As much as you can, you want to get in the habit of seeing similarities. That line works just the same as the previous one. That is, I should end up with 2D plus 3S equals $16.25. And that's my second linear equation here. So now I have my system of 2 linear equations, and we're going to look at solving this. Any of the problems we're going to look at, you could use substitution or you could use elimination. Some problems seem made to use one or the other, and I'm going to say that this one is really designed to use elimination. So I'm going to use elimination. I'm going to do it 2 different ways to show you some more examples of how elimination works. But to start with, looking at this, I notice the first equation has a 3 in it, and the second equation has a 2 in it. So I want to end up with a result so that when I add the 2 lines together, one of the variables cancels out. So what I'm going to do initially is I'm going to take the first line and multiply it by 2. And follow along with me if you've not seen this or this isn't seeming to make sense, and see what happens, because in my experience, most people, once they see it, they kind of get why we're doing what we're doing. And we'll talk again about why we're doing this in a second. Since I had 3D in the first line, I'm going to multiply the second line by 3. I'm actually going to do a negative 3, because a negative will work the way I want it to. So again, I took the first equation, multiplied it by 2, because this coefficient here. I took the second equation, multiplied it by negative 3, because of the 3 coefficient there. Doing that, I'll write these off to the right here. Doing that gives me the first equation is now equivalent to 6D plus 8S equals, I think that's going to be 4450. The second equation will be a negative 6D minus 9S equals negative 4875. And what you should notice here is that my next step in elimination will be to add together these 2 equations. Adding them together, the 6D and the negative 6D will cancel each other out. The S terms, well, 8S minus 9S, I should be left with a negative 1S, or just a negative S, equals, well, subtracting 4875 from 4450 should give me the result here, and that should be a negative 425. Multiplying through by a negative 1 with this resulting equation tells me that S should be 425. So I've got one variable. I know what the amount of S is, the value of S is. Now I need to pick one of the 2 equations to plug S back into to give me D. They look about the same here, so I'm going to pick the first one. So that should be something along the lines of 3D plus 4 times 425 equals 2225. 3D then Well, 4 times 425 should be $17 equals $22.25. Subtracting the 17 from both sides, we get 3D equals $5.25. Dividing both sides by 3, I should see here that D is going to be $1.75. Alright, and that's certainly a way to get through the elimination. So the drinks cost $1.75 each, and the sub sandwiches $4.25 each. I said I would do this 2 different ways. I'm going to set it up so this work is one way we can get through the elimination. Another way is to multiply in such a way that the s's will cancel out. Well, I should notice for the s's, I got the 4s, I've got the 3s. For the s's to cancel out, one easy way to do this is to multiply the first one by 3 and the second equation by -4. Doing that, I'll get 3 times 3d plus 4s equals $22.25. The second equation I'll multiply by -4 to give 2d plus 3s equals $16.25. Once I do that, the result I'll put right below that should be 9d plus 12s equals $66.75. The second equation should be a -8d minus 12s, and the result of that should be $65. It's looking like. I'm sorry, the sign should be -$65. Alright, adding those 2 lines together, again, we see one of the variables cancels out, which is the point of elimination. Again, the idea with elimination is we're eliminating one of the variables. Adding what we have on the left-hand side together, 9d plus a -8d rather, should be d, or 1d. Subtracting the right-hand side, I should see that d is 175, which looks just like what we saw over there. To find s from here, I could again plug d into either side of the equation. Let me give myself a little more room. And since I can still see the second equation, we'll do the second one. So 2 times d here is 175, plus 3s should be 1625. 2 times 175 is 35, plus 3s equals 1625. Let me make one correction with that. 2 times 1.75 should be 350. I gotta scroll down a little further here to give me some room. Subtracting the 350 from both sides, or the 3.5, that's how I read it, I'll be left with 3s equals 1275. Dividing both sides by 3 to get the s by itself, I should be left with 425. And again, I see that d is 175 and s is 425. All correct roads should lead to the same correct answer. So this being another correct method, way to do elimination, I should get the exact same thing I did before. I do, and that looks good. You certainly don't need to do elimination twice here, but I wanted to show you a couple of different ways elimination could work on this problem. I hope this helps.